Very good to see this.
Yeah, yeah, you can see.
So, uh, yeah, I mean, what the plan was to just scan through what was taken in the first session. We are not going into too much of details, but we will just look at uh, what PGM means, right? That's what we did last time. So we will just um, run through it. We will not go into detail of what exactly the professor said, right?
Yeah,
But there is something which we need to focus, so we will just go through that in the next 30 minutes or so. And then, Manoj, I think you will do something similar on the DL side, right? So
yeah,
let us
that
get
sounds good.
started.
Yeah,
So PGM basically is whatever the professor said, right? It deals with uncertainty. So and that is the reason why it's called probabilistic. So it is a PGM basically deals with the topic subject where we use graphs along with probability to make certain models so that we can actually make decisions under uncertainty. Right? That is what is the focus area. Okay, so as I said, I'm not going to go in detail of every line what the teacher also was mentioning. So we'll just go through some of the important points which we saw over here, right? So uh, one thing which we know is that generally we are able to recollect from the previous semesters. We remember certain writing certain tables which are related to joint probability and all that, right? Let me see if I did have some examples which I opened up. Let me see if I can find something. The biggest challenge is that I cannot write in share, so I pull up some example which is there on the internet so that it's easier for us to do. Yeah. Simple, simple. So I should have opened and kept it so that it's easier for us to get here. Just this is not simple.
no, otherwise we can continue, I think.
Okay, and now okay, I did share my desktop. I think I shared my particular slide with them, right? Let me just share my desktop. Screen to screen where is the screen? Yes, okay. Okay, okay, now this is better. Okay, so basically when we had to write joint distributions, this is how we were writing, right? So I'll not go into details of it, but what happens is like we create a tabular structure where we will have for each and every variable we will have a probability, and that is how we had been just trying to find something good example. If nothing, then I will pull up a Word document. And, sorry, need a Word document. So, insert. Okay. So basically, let us say that we have male, female, and then this will be the total. And on this side, let us say that I had say gain one, gain two, and here I will have the total again. Right? So let's say that 10, 20, so that it will be 30, 30. And let's say this is 5, so this will become 15. And I need, let's say, 30 plus. Give me some numbers so that I can make this say 30. So here it has to be 10, this will be 5, so this is 25. Right? 25 plus 15 is 40. 40. Now, say this is the thing, so I'll now write the probability. So the probability of this is 1 by 3, right?
1 by 3.
And
Okay.
similarly, this is 2 by 3,
Mm-hmm.
this is 5 by 10, which is
1 by 2.
1 by 2, and this is
1 by 2.
1 by 2. So this is in total, this total probability would be 1. Okay,
Mm-hmm.
so basically, if we have to write this in terms of probability, this is 3 by 4, and this is 1 by 4. So
Mm-hmm.
these are the marginal probabilities. These two is the marginal probability. For example, the marginal probability of male is 15 by 40. The marginal probability of female is 25 by 40. And this is the total probability of all these instances. Similarly, the marginal probability of gain 1 is 3 by 4. The marginal probability of gain 2 is 1 by 4. Right? So this is how, so if we look at this, if now this is just for two by two metrics, right?
Mm-hmm.
Which is like two games, and I have two variables. If we have to do this for a large set of variables, then what would happen? So that is the complexity which we are talking about. And that is the reason why we need there was but we still require probabilities, because nothing in this world is static or known to be a 0 or 1, right? So that is the reason why we need now okay, conditional probability was each of these columns, okay, where I would say like probability of gain 1 given male, right? So what would that be? Those are the kind of things which we would want to actually find out. And that is the reason why if we actually employ the graph theory also, right, we will be able to eliminate a large set of values where there is conditional independence. Now, what does conditional independence mean? Say, for example, the probability of someone playing game 1 is not dependent upon whether they are male or female, right?
Mm-hmm.
Then the probability that of game 1 given male or probability of game 1 given female is equal to the probability of game 1, which is same, right? So that means I can actually eliminate that one row from that table. And how would I know that? So to do that, the best way of accomplishing that would have been to actually draw a graph like this. So these are all typical graphs. So there is an example over here. Okay. So if we had drawn a graph like this, so this is season and the influence of season on flu, hay fever, etc. Right? So that is what is given over here. But if I had drawn a graph like this, if I had not drawn a graph like this, how would you represent this? You would have had season on one side, you would have had flu, then you would have had season given flu, season given hay fever, you would muscle pain given flu, congestion given flu, congestion given season. All these various combinations would have been required in your set. Only then you would be able to solve the problem. Now, if we are able to pictorially depict the conditional independence, so because the reason being that flu and I cannot have a hay fever given flu, right? But the season influences me getting a flu or me getting a hay fever. But
Mm-hmm.
me getting a flu because I have hay fever is not existing.
Yeah.
So if I had pictorially depicted this, then I would have been able to eliminate a lot of these cells over here, which are not really required for my computational purpose, and therefore I would have been able to write the probability of season, flu, hay fever, muscle pain, and congestion in a more simpler way, where I would have been able to eliminate a lot of factors from the probability calculation. So, for example, probability of flu given season and hay fever is equal to the probability of flu given season,
Okay.
right? We don't have to have the season. So this would have been otherwise expanded as probability of flu given season, comma hay fever is equal to probability of flu given season uh, into probability of season given hay fever,
Mm.
right? That
Yeah.
is how we would have expanded this based on the the chain rule,
Mm-hmm. Okay. Mm.
right?
Yeah.
So in this case, because we had this graph, we are able to eliminate that because we know that there is no, I mean, season cannot be determined by hay fever,
Mm-hmm.
right? So there is a conditional independence of me having a, I mean, of the probability of flu given season and hay fever is very minimal. So we are able to remove that conditional independence because we have this picture where we say that season will influence flu and hay fever, not that hay fever will not influence season.
Ah.
Okay, and that is what we were. That is the basic idea which we were actually having in the last class.
Mm-hmm.
So this is what we basically went through. There were a few examples which Sir showed, I mean, these are actual applications which we looked at. So I will also run through the applications for the benefit of for example, during our exam, if we are supposed to write example or something, we will be able to recollect it, right? So here, the first example which our
Uh,
professor went through was the Microsoft Lumiere project.
yeah.
So
Can you
what
please expand it, maximize this slide so it will be easy for me to read?
okay.
This slide is a small one. Yeah. Now it's a good. Yeah. Okay. Thank you.
Okay.
Yeah. Yeah. Yeah.
Um, okay. Was everyone who is joined the meeting able to follow what I explained before?
Only I am there. Yeah. Others left.
Oh, okay, fine. So, okay then. So what we the first example which Sir mentioned was the Microsoft Lumiere project. Okay. In this, what Microsoft tried doing was to come up with suggestions like this,
Mm-hmm.
right, based on the user's previous actions or search, right? If, for example, like if I move the mouse over here, here, click on something, something, so all that data was collected, and based on that, the project would actually recommend some actions. right?
Okay.
And for that, they had used a PGM, which is like graphical representation of the data set which is collected and the probability of that action happening. And then, based on that, the best actions were taken and represented, right? It's like, okay, for example, if I say the user having clicked on data and insert and tools, right? Um, and after doing all this, the number of times he tried to sort the list was, say, X, based on that representation. And all, I mean, otherwise, there would have been a lot of things, right? Saving the file does not depend upon me going to the data set. So that would have been eliminated, for example, from the when this particular action was being um, performed, right? So that could have, I'm just understanding the project from the explanation, but that could have been the way the graphs would have been used to eliminate some of the dependencies between the actions. Okay, so let us go to the next one, which is this is a life science. So one more thing which sir was mentioning is these are mostly used in the area of biology and chemistry, right? Because there is a, I mean, this was mentioned in the graphical modeling class, but if you see, the most of these applications are in the area of life sciences and all that because there is a lot of data and a lot of variables in those areas, right? And but now it is getting applied in a lot of the networking areas and all that. But previously, it was the initiatives were mostly started in the area of life sciences, biology, chemistry, etc. Okay, so this is basically a land and farm management option. So if you see over here, there are so many variables, right? But some of these variables are having more importance, and that is why it's highlighted, whereas the others are not having so much of importance. So if I had to only look at this particular chain, I know that this does not have dependence on these things. So I can actually eliminate those records if I only want to find the risk of a flood and typhoon and damages. I don't have to look at all these set of variables which are not linked to this, right? This is one another example which was there. Sir has told that we can read the papers and had provided the papers also. The next is here it is the medical diagnosis. So this basically again in the same way, this was the early setting of what was that? Not amnesia.
Archimedes.
Mm, yeah, Alzheimer's, correct. Right? So for the same way, like if we knew that what all are the parameters this particular model uh, had been created, then if a person has similar kind of attributes in the early stages, we could have done the early diagnosis, and that was the advantage over here. Right? So this was another study which was done using graph theory. And yeah, this is one more. This is the stillbirth rate, right? So in this case, like the identifying how stillbirth rate could be improved, which means stillbirth rate is death of a baby in the womb, which is like before the child is born dead,
Yeah.
right? So how can we actually eliminate those cases, and what are the parameters which are impacting that? That was the study which was done, and it was found that like uh, better better skilled nurse availability and all that would will cause an improvement in the stillbirth rate, which is it lowers the stillbirth, right? So which will actually which is better, right? So that is something which was done. So again, this is also in the area of medical field.
Yeah, but how you understand from this graph? I don't understand anything from there. This one.
So actually, there are papers which are mentioned, but the thing is here, like this is the birth rate, still birth rate, okay?
This.
And this actually, if we look at
Still.
these things,
Hmm.
it's actually showing certain the different percentage, right? The 24 percentage, etc. The influence of various parameters on that, on each of these things. So depending on that, it has been determined actually.
Hmm. Hmm.
So for each of these parameters, they have actually captured a percentage.
Hmm. Okay.
So I think we will have to go through that paper. And this is the gesture recognition. So the gesture recognition, what sir mentioned was like you're lifting your hand to stop something, to show the stop sign.
Hmm.
But the same sign could be used for also saying that go ahead. But you will still start your action by lifting the hand, right?
Hmm.
But at the end, the last signal might be like you move the hand forward instead of just holding it,
Hmm.
right? So depending upon the different type of variables and the probability of you doing certain things, like so it's like okay, I've done this in the first time, I've then done this action, then done this action. What was the probability that I made the stop? So these are actually captured as graphical graphs and all that, and then based on each of these hidden states and whatever is the intermediate probabilities of each action, the um, action was taken. So these are all actually very difficult to depict pictorially. Okay, I think the most um, this attention deficiency, you could still do a prediction. I mean, this is much better explained or visibly okay because the others, right? They
Hmm.
are having too many parameters that it will be. It's very difficult for us to actually represent and tell something. But if you look over here, right?
Hmm.
See, if attention deficiency is determined by gender, etc. But if I had to say whether my IQ would, what my IQ would be, it is not dependent on gender,
Gender. It starts
right?
from the gender, no?
Yeah, this is starting from the gender, but
Hmm.
this way it's not, right? So here is my IQ. So attention deficiency depends on my IQ, but the reverse is not true, right?
Attention. Ah, this comes from the. Okay. Okay. So that on the right side is a different scenario. Top is different, right? And it is going to left. Okay. So.
Right. So basically, if I have to calculate attention deficiency, these are the parameters which are impacting. But then, do I need to know, considering that these are, see, for example, perfect IQ. If I know this, then I don't need to know the value of verbal IQ or full IQ to determine attention deficiency, right? Because they are not directly dependent. And the same way, my whether I'm right-handed or left-handed determines my whether I have aggression or not. But the reverse is not true, which means that for finding out whether I have attention deficiency, I need not know the probability of this right-handed handedness on aggression because attention deficiency is directly linked only to aggression, right?
Hmm.
It doesn't impact this. So I could eliminate this variable when I'm only looking at this.
Hmm.
But provided that I know the value of aggression given my handedness, I don't have to have any of this value individually captured. So putting it graphically, I am able to eliminate many set of variables which I would have otherwise had to capture and calculate.
Hmm.
Okay, so that is the reason for all what we are looking at now is the reason for having graph theory and probability theory together, right? We are not solving anything or we are not creating any algorithms till now. We are only saying these these are the reasons why we could we will be able to we if we bring graph theory and probability theory together, this is the advantage which we will get in being able to do a algorithm or a diagnosis or a inference.
Mm-hmm.
Okay. So we are not solving any problem till now. We are only giving simple examples where we are saying, okay, because this is like this, if we had since we have used graph theory, we were able to find out those variables which were conditionally independent. And if it's conditionally independence, I don't have to write like a given b comma c can be written as a given b. If b and c are mean a is conditionally independent of b and a is conditionally dependent only on b and a is conditionally dependent only on c and not on the combination of b and c. Then I don't have to have too many probability of b given c, right? I only have to have the probability of a given b or probability of a given c, but not the probability of b given c,
Okay.
right?
Yeah. Mm.
But, I think if I made some notes and then shared it, it would have been much easier. But for the time being, I would like if you could understand that the need of graphs or the advantage of having graphs along with probability calculations to make the calculation simpler and to make and therefore uh, add value to the various inference algorithms. That is what the algorithms will be, what we will be learning. But the why it's advantageous to have graph theory along with probability theory and not just probability theory or graph theory.
Mm. Okay. Mm.
Okay, that is what we are looking at. Like, why is it better to not have individually either of it, right?
Mm-hmm.
Because in graphs, we only know the dependencies. We
Mm.
don't know the which node will have what impact,
Mm.
right?
Yeah.
So, and we know that things are not certain. So it's not like every time I have, season is a winter, I will have a flu. There is there is a percentage.
Mm.
So if I only had a graph, I would be saying that okay, if season is this, I will have flu and I will have hay fever. That is not what I want to say, right?
Mm.
So I want to say, okay, if season is this, the chance that I can have a flu is this much, or I can have a hay fever is this much,
Mm.
and that is the uncertainty.
Yeah. Yeah.
Okay, so now you understand, right?
Yeah.
If I because I have graphs, I'm able to eliminate that the condition that given hay fever, a season can be predicted, or I, given flu, sorry, the probability of having a flu given hay fever is not important in this case, can be determined using the graphs,
Mm. Okay.
right?
Yeah.
But the percentage of each of these things in occurring will give us in kind of like diagnosis and all that. That uncertainty can be brought in by using the probability.
Mm-hmm. Yeah.
Okay.
Yes.
So yeah, basically that is what we have been going through. I would actually suggest that you go through this. So he has also given one size calculation over here where he says like, say for example, there were 4 seasons
Mm.
and condition had 2 values. Muscle pain had an yes or no. That is, these are all binary, right?
Ah.
So whether I have congestion, whether I have muscle pain, whether I have hay fever, whether I have flu, and
Mm.
say that there were 4 seasons, I would
Ah.
have had a sample space of 64,
Oh. Mm.
right? Now, if I know that, if I have flu, or say, for example, if I know that um, the season is, say, summer, I would have been able to eliminate a lot of these based on uh, the conditions which I would have been able to identify, right?
Yeah.
Because, I mean, for example, like season two, hay fever is a separate chain. So, what would have happened is when I'm calculating the sample space, it would become 4 into 2 into 2 if you remember that particular graph, right?
Yeah.
Because season is related to flu and flu is related to congestion and muscle pain.
Mm-hmm.
So the calculation would be 4 into 2 into 2 into 2. This 2 would be eliminated.
Mm-hmm.
Okay, so that is 32. Now for hay fever graph, the data set which would be required is 4 seasons into 2, which is 4 into 2 is 8,
Mm-hmm.
right? So now the total sample space would be 32 plus 8.
Mm-hmm.
So for just one, by just being able to eliminate one line, I am able to reduce the required sample space, right?
Mm-hmm.
The size of the data which I would be required to process.
Yeah, but flu and hay fever both are related to season. So how in one case we are reducing the two, and in other case we
Yeah,
are reducing most
uh,
of
it
other.
was identified in the example, we had identified that hay fever is not related to, okay, hay fever is related to congestion, but not to muscle pain. So there will be one more into two. Okay. I thought
Okay.
this line also I took off. So this is 4 into 2 into 2
Ah,
into 2,
ah. Plus
right? But here, because here, this is not relevant here. So it
ah,
will be 4 into 2 into 2,
okay.
right? So the total amount of probabilities which we have to store is this plus this.
Hmm. So hay fever
But
we have two, or is it only one? No.
two values, yes or no.
Yes or no? Yes. Right. Right. Yeah.
Right? So that is the reason.
Yeah. Even if
So
we don't have a
season
child
test.
there. Yeah.
If we didn't know this,
Yeah.
what we would have had to capture would have been, I mean, for all 4 seasons, we would have had flu, hay fever, muscle pain, congestion,
Yeah.
right?
Yeah.
So, and I would have written all the 4 seasons over here and all these other variables over here, and I would have had a tabular structure which is like 4 into, here there will be 4, and for each of these, there will be two values, right?
Yeah. Yeah.
Flu will have yes, no flu, that way. So that would have been the amount of data which I would have had to process.
Mm-hmm.
But because I now know that this is not having any relevance over here, I don't have to have a combination of season, hay fever, congestion, and muscle pain.
Yes. Mm.
That
So.
record itself is gone.
So that will be season into flu, that is 4 into 2, then in muscle pain that will be into 2, and so into 2. So 4 into 2, 8, 8 into 2, 16 is 32. For the
Correct.
and the right side it will be 4 into 2, that is 8,
2
8
into 2.
into 2, that is 16.
Huh.
So 32 plus 16, 48, right?
Correct.
Uh,
Right? Otherwise, it was 64, right?
yeah. Why they are taking 64? That's a normal
No.
method of taking, yeah?
Yeah. Because I would have had all the combinations, right?
Mm-hmm.
Season, flu. I
Mm.
mean, flu equal to yes, flu equal to no. Season, hay fever equal to yes, hay fever is equal to no. Season, flu, muscle pain.
Mm-hmm.
Season, flu, congestion, right? Again, two combinations of values. Again, two combination of values. Season, hay fever, flu, muscle pain. Season, hay fever, flu, congestion. Again, two values. So all that combinations would have been there, right?
Mm-hmm. Okay. So in the probability we are generally taking like that, or this is I just want to understand, like we are this is the method of taking in the PGM, or um, this
So
is a
in
simple.
no, so in general probability, so for example, how we would have written this would be, right? I mean, not with, if we didn't have this diagram, okay, what we would have written is probability of season and flu, hay fever, muscle pain, congestion, right? Probability of all these parameters would have been equal to. Can you write it down? You will understand better. Okay.
Yeah.
Probability of S comma F comma H comma M comma C.
Wait, 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 let me just take the book. Season, flu. Hi Nagesh.
Hi Manoj. Hi Praveena.
Hi.
Congestion.
You wrote it, Manoj?
I am writing here. So yeah, yeah, I draw this diagram. Now I have to write for.
Don't draw the diagram.
Oh,
We are not looking at the diagram now.
okay.
Just
No
write
problem.
probability of S comma F comma H comma M comma C.
Probability of S comma
Nagesh, you may also write.
Yeah,
Okay.
yeah. Thank you.
S comma F.
Probability of S comma F comma M
H
comma
comma M comma C.
okay.
I'm taking the first letters of each of these random variable. Okay.
So H also,
Okay.
right?
Yeah.
Okay.
High fever also. Okay.
So I
So
will
one,
do.
two, three, four, five, right?
Yeah.
Yes.
Yeah.
Okay.
Okay. This would have been in the normal chain rule. This would have been written as the first step would be probability of S given F comma H comma M comma C.
So that will be
Okay.
I'm
okay.
expanding every line one by one. Okay.
Okay.
So the first time I will say probability of S given
Mm.
F comma H comma M comma C.
This given thing is a perpendicular line, right? One bar.
Yeah,
One bar.
a slanting line, not a perpendicular line.
Yeah.
Yeah.
It's a left slash or right slash. Left
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 side.
slash.
Okay.
Okay.
Yeah.
Now I will expand that to probability of S given F comma H comma M comma C into now the just the next one the F comma H comma M comma C should be now mm, taken, right? So that part. So each time I'm going to expand the denominator.
No, oh,
Okay.
okay, okay. First one is S given F comma H comma M comma C. Second one is S given
Probability of S
uh,
into
into. Okay. Uh,
probability of F given H comma M comma C.
oh, okay. Understood. Actually, we are dividing the conditional probability
It's not
for each step,
dividing. We are
expanding.
actually applying the chain rule, right? It's
Okay.
not dividing. It's actually we are incrementally applying the chain rule for the next value.
Okay.
So
Okay.
I mean, it's because so that you people will understand it faster. I
Yeah,
could
yeah.
have written it in one go, right?
Yeah,
But
yeah,
instead, I
correct.
want you people to understand it.
Yeah,
Right?
yeah.
In the
Thank
next
you.
step, what we will do is we will say probability of S into probability of F
F. Oh, okay.
into probability of H given M comma C.
Okay. Yes. Okay.
Right? The next, we will again expand that as
Probability of
probability
S in
of A
multiplied by
given
probability of
into
F.
probability of M given C.
F into probability of.
Sorry, I think I made some mistake. Okay.
Okay. I think this is the last step.
Yeah, this is the last step, but I think I made some mistake.
Okay.
Mm, I think I should have started from the reverse end.
Oh, okay. Reverse in the sense we should start from C, probability of C.
No, 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 no. Whatever is in the denominator should have come in the numerator.
Oh, okay.
Sorry, write again. Probability of S comma F comma H
M comma H given
comma C.
probability of C.
Yeah. So the first is is correct. The first is probability of season. Probability of F comma H comma M comma C given S.
Okay. Oh, yeah. I think actually we have to go from the root node here.
Correct.
Okay, because that should be season is given ultimately that is fixed for
Right.
everything for all conditions. Season is fixed given season.
Correct.
Okay,
Right. So
so probability of muscle pain given probability of F comma I mean C comma H comma S.
correct.
Again probability of F given, sorry, probability of M multiplied by F given probability of C comma H comma S.
Yeah.
Is it?
So
Okay.
okay. So that okay. This is a very complicated thing. So what I will do is I will write this once again.
We got the logic. No problem.
I will write it in detail and I'll share it on mail. Okay. I mean,
Yeah,
I
yeah,
will.
that's fine. But we
Okay.
got the logic. Thank you. Yeah, I
Right.
think
So
Arun also,
the
Manoj also got it. Yeah.
what we are trying to say is like when we have to write this, right? The number of
Uh-huh.
factors which we have to look at for the probability is very huge because we have to
Yeah,
look at
yeah, yeah.
any combination. But if
Correct.
we have now got this graph like this, we already know that I don't have to have the probability of flu given hay fever or probability of muscle pain given hay fever. Those
Mm,
combinations are not required because, for
correct.
example, over here, right, probability of flu given season and hay fever is equal to probability of flu given season because hay fever and season are related, but season is not flu is not related directly to hay fever. So
Correct,
if we
correct.
have
So the
such a
condition is only to season only, not hay fever, right? For flu.
correct, that is what we want to
Because
do, right? So
yeah, yeah, yeah. That's what I also confused because flu is nowhere related to hay fever because it is not conditioned by hay fever. These two
correct,
are independent and these are not dependent things, flu
right,
and hay fever. So
right.
the
So
dependent things are flu, muscle pain, flu depending on season, and muscle pain is depending on flu and season.
correct.
Okay.
Right. So when we are expanding, if we
Hmm.
will, if we had gone only with the chain rule, we would
Hmm.
have had a lot of factors
Hmm.
which we would have had to consider, for which we would have had to calculate the probabilities if we had
Hmm.
not known this. Right. So, for example, this itself will have had to expand. For example, probability of flu given season
Hmm.
and hay fever will have to be expanded for both flu given season and
Hmm.
season given hay fever. Right? So
Season
those
giving. Okay. Hmm.
right, so those kind of things are no longer required because we already know that hay fever and
Actually, here in the second equation, probability of F given, I mean flu given season and hay fever is constant, which is not relating to, which is not depending on this one. That's why that equal to it doesn't matter. We need not consider hay fever at all. That's why it is equal to
correct.
P probability of F given S only.
Yeah, but how are we able to know that? That is because we
Hmm.
have represented it as a graph. If we had
Hmm.
not represented it as a graph, we would have
Hmm.
expanded all this, right?
Exactly,
And
exactly,
we would have
exactly.
tried to find the probability from the data from some data set. We would have had to try to find the probability. We would have
For
spent
everything.
try to
Yeah.
do that.
Yeah. Just
We would
because
have
of graph only, we could able to perceive it. Otherwise, yes, yes.
But
Okay,
say,
that is what we are trying to prove.
uh,
So
m-
since
uh,
we had graph,
yeah,
we are able to eliminate a lot of requirements of data and processing.
but
Okay.
see, this season, this graph came from the domain expertise, no? Otherwise, how can we get this
Yes,
graph?
yes,
Absolutely. Yes, yes. That's why domain expertise is essential here.
essential in this case, right?
Hmm.
Without that, graph can't be developed at all.
To develop the graph, domain expertise is required.
Yes. Yeah.
So here, probability is not mentioned, right? Or
No, but
No, actually, no numericals are there. Only we are just considering the
yeah.
conditions. What is to be, what can be eliminated through graphs. That's what the aim is. That's it.
Mm-hmm.
at a later point in time, when we are actually doing the numericals, we will understand that
Hmm.
I mean, if I had to write all this and find the probability for each and everything, then I would
Hmm.
have had to find a lot of more numerical values
Yeah.
to be applied over here, right? So from the data set, I would have had to calculate the dependency on flu on season, flu on hay fever on flu, all
Yeah.
kind of things I would have ended up calculating, right?
So much calculation
Yeah.
we can eliminate. Actually, as per my remembrance, he might have told that around 16 combinations out of 70 plus combinations, right?
Correct.
70 plus total probabilities that
Yeah.
we
So
we
in
reduced.
one in this scenario, he had done a calculation of 64 for all the sets, which is 4 into 2 into 2 into 2 into 2.
Hmm.
Right. This is the sample space if we didn't know this graph. Right. So
Yeah.
this now since we know the graph, for this line there is one. I mean, for this set we have one, and for
Hmm.
this side we don't have an influence of this. So we have reduced the number of values which we would have had to calculate in this case,
Yeah.
right? So for me to be able to find the chances of flu given a season, I would have only had this much data. The probability, I mean, if I wanted to find the chances of hay fever given the season, I would have had only this set of data. That's how it is, right? Because this does not have an influence on that. And similarly, if I only want to, if I want to find conjugation, then I only need to know the probability of hay fever and flu. I don't need to know season because if I know this, because I only need this much value.
And it automatically includes the dependent value
Correct.
in flu itself, right?
Right. The
Ah,
influence of flu on season and influence of, sorry, season on flu and the influence of season on hay fever is already taken care by this probability individually. Right. So
yeah, yeah.
if I am only interested in this, I will not have to go till here.
Yeah, yeah. Actually, it is a kind of corona symptom is when actually in a corona time, corona is already there that we know, and we
Mm.
have fever, and we have a cough is there. So the at the time, if fever is there, means already corona is there
Right.
in that situation. That's okay. And for already cold is there means already fever is there, and so that corona is also there. So in cold itself, it is everything is covered. I mean, it's not correct thing, but I think maybe, yeah.
Yeah, I mean, I understood. So you are just trying to make up examples, but
Yeah,
similar situation, right? If you know the immediate parent, then the
uh,
parents' influence is already taken care in the parent, so you don't have to go any further
the-
to the parents' probability.
yeah, parents probability, yes, 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 yes.
I mean, grandparents' probability.
Yeah, yeah, yeah.
Manoj,
Yeah, yeah.
you are kind of understanding, right? I will actually write some more theory of expanding these formulas and I'll give it to you. Okay.
Okay, okay, yeah.
But you have understood the idea, right? Why we require graph and why we require, I mean, why graph and probability together will be better rather than only probability or only graph.
Yeah, like what I understand is if there is one table given with all this data, snow and season and all, from there, finding the probability will be take too much of work. But if we have a domain expertise and if we make a graph like this, then the number of features or what you say the probability,
Features only, correct,
yeah,
correct,
that
features
will
only.
be
The
reduced. Yeah.
ultimate aim is to reduce the frequent features, what are essential features to figure out the reasons. I mean, actually the that's it. So to map and find the final model. So
Okay.
because if we because the combinations of the features are so many, so huge in when the kind of for practical use cases, it's not just 4 5 variables or some that out of that we need to figure out something like that.
Okay. Yeah. Mm.
So the
And
idea, so the reason for using graph is to find the conditional independence, right? So if we
ah
find a particular feature is independent of another feature, then
yeah,
we don't
yeah,
have to think about the dependence of that feature on that the other on that feature, right? I
yes,
mean,
yes,
Mm.
correct, correct,
Yeah.
correct,
if feature
exactly,
one,
proper word.
if we
Conditional
already
independence, right?
identified that
Yeah.
feature one and feature two are not dependent,
uh,
then we don't have to look at the conditional dependence of feature one on feature two or vice versa, right? So,
yes,
because
yes,
we
yes,
already know that they are independent. But how do we
correct,
actually know that they are independent? And for that, generally, these areas are not like with one or two features that we can represent so easy. I mean, we can know very easily, right? So
yeah, yeah,
representing it with graphs and identifying the influence of each feature on each other will actually help. There would be certain features which have mild influence, and then we might decide that we don't want to use that mild influence on the, and so we will then go ahead and consider them as independent
correct,
itself.
correct. For
That
example,
also.
one probability, if it is more less than 30%, and one feature has 90%, then we obviously choose the 90% and we can ignore the 30% thing, which is very less in case.
Right. So all that will, and because of that, we have graph theory and probability theory together. And that is the reason for probabilistic graph models.
Actually, I like to learn this stuff. It's very interesting, right?
Yeah,
But
very interesting.
Yeah, that's what.
Actually, out of all the subjects, even though I'm poor at maths, Praveena and Manas, I like PGM subject only. I don't know, so much attracted to this one.
yeah,
I
but the problem is you know much better max than me. So, but I don't know how I will be after
no,
Okay,
no, no, no,
so
no
Manoj,
issues.
midterm
I think
exam.
Praveena will be there for us.
Yeah, yeah.
I will write this better. I mean, on the fly, it was difficult for me to write the formula because I get missed. I got missed up in the expansion. So I
Yeah,
will sit peacefully and write the expansion so that it'll, and then we can probably like take arbitrary values and all that, and then um, if I explain it like that, you might be able to understand it better, right? So I will try to do that. But at the moment, the main idea is like tomorrow we have classes again, right? But
Yeah.
before that,
yeah,
you need to get an idea of why we require graph and why we require probability together so that it's more efficient.
Yes, yes.
And this probability calculations anyways will come in one or two lectures later, and I think next class is going to dive into probability and all that. So at the end of that, by the end of that, might be next week, if we get into this expansion and all that in detail, you'll be able to understand that area.
Okay, okay. And
Okay, so
actually, one thing I requested one of the seniors I met. So I requested him, and he sent me some comprehensive exam questions of DL, SPA, and this guy BDS. But he's in not in PGM.
PGM.
So if you
Uh,
have any seniors who is in PGM, no, please try to collect some question paper because we don't have a single question paper for mid or and so.
we'll ask him tomorrow. We'll let us ask him only, or because actually we'll tell them in chat box or something. Definitely, we should ask. Otherwise, it's we'll try. We'll give a try.
okay.
Request him if he
I
gives
don't
the.
I don't know any seniors who had been in this one actually. My friend actually studied software systems, so
Mm-hmm.
I'm ready to get PGM from him. But
I
he
too.
did
But
have IR actually. He had
we'll ask him only, Parvina.
yeah, that's what
Our tutor
we will
only.
ask
Yeah.
our teacher only
Uh,
to give us some sample question paper. Otherwise, we should probably look into all these. Online, lot of people would have uploaded some of the other question paper. But this paper, not many people have taken in the past, I think.
Not a
How many
single
how
question
many
paper
how
is
many
there.
students total, if you have an idea? How many students
Not,
opted for this?
no, I don't know in total
I think
because our
30 is
also,
there.
Approximately.
30
Around
I
is
think,
there.
above approximately around 100 or less than
no, no,
100
no,
or
I think only 40, 50 people have taken, I think.
is it 40, 50 people?
Yeah, I mean, after that, I don't know if somebody has taken, but in the initial count which somebody has circulated, I think around 50 people or something was there.
Oh my God. Okay. I'm scared of the grading because you intelligent guys will have a high score than if I have a very less score than.
No, 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 don't worry. Uh, and because and the thing is, there were a lot of people for BDS and all that, right? So the number of people, if we put an average of those count, then we will understand. Only DL is mandatory. So if we get the complete count of DL enrolled, then we will know what percentage has gone to what.
Hmm.
Because DL is mandatory, right?
Yeah,
So
for
if
everyone,
we
yes.
get the count of all the three uh, sections of DL, then that is the maximum number of students who will be there for one subject.
Hmm.
Maybe 800 are there.
Okay. Then I know that like
Not even
um,
10%.
okay, DL first session DL was Sita ma'am, Chetna ma'am's class, which is NLP, right?
Hmm.
NLP first section had 350 students already, and it was full. Then I think the other two had more. One class had near about 300 or something. So in one sub, that means NLP also most people have taken.
Yeah, most people NLP taken, yes.
Now, what is the rest of the subjects?
PGM and graph modeling.
IR is there.
Um,
IR,
IR,
information retrieval, yeah.
IR,
And
BDS, SPA,
uh, two
PGM,
graph models, graph
and
models and PGM, yeah.
uh, GAM, right? And
Hmm.
BDS and SPA also, a lot of people had taken. So let us say
SP
that
had taken so many people. Okay.
out of 800, one subject, out of 800 people for one of the subject, let us say NLP was taken, then three for the next three subjects, we have five subjects over here. Out of this, BDS and SPA, more than 350 people each have taken, right? So
Hmm.
then for 350 people is gone from the list. So between PGM, IR, and GAM, there is a count of 800 minus 50. Sorry, 350, which will have to be divided.
450.
Yeah. So yeah, approximately that means students has been divided among the three subjects. That is what I would go with. We can do a
Hmm.
better calculation, but approximately only less than 100 people would have been there, will be there in each of them. That's for sure. Because I know that BDS, SPA, first section, they have two or three, two sections or three sections, okay? And each
Hmm.
first section,
Correct.
first one teacher was fully occupied, like 350 was there. The other two had some people in it. So which means more than around 400 students have not taken PGM, IR, or GAM. So
Hmm.
for two subjects, PGM, IR, or GAM, the rest of the
Hello. Hello.